Hi, everyone. Welcome to the show after the show. This is the Nature Chat, where we talk about what happened on Nature Check and talk to one of the scientist players about who they are, what they do, what happened during the episode, some science stuff, all of that good stuff. So as a recap of what happened during session 3 of Nature Check, the heroes were immediately engaged in battle with some sort of amphibious creatures. They defeated those creatures and then set about collecting gilderweed in the seagrass beds. As they were collecting gilderweed, Fletcher accidentally pulled up a clump which freed a trapped water elemental, and so they were thrown into combat yet again. But everyone survived, so yay. They collected the gilderweed and also some stuff which was not gilderweed but looked very much like it. They took all of their findings back to Elsa Wentz's apothecary shop, where she paid them for their foraging, and then they went on to the brothel to help Carissa. So Lucanus was able to barter to take her out for like a date night on the town by paying 10 gold to get her out of the brothel, and then the group took her to a secluded beach spot, gave her the gilderweed, and she transformed into her mermaid form and swam away into the ocean. So happy endings all around. And then there was some quick sale of weapons that had been found on the bodies of the weird amphibious creatures from that first battle. And then we left on a bit of a cliffhanger because Artemis had just noticed a gentleman at the bar in the Marked Bird complaining to the owner, Leon Feist, about something, but we don't know what yet. So that's what happened during session 3. And we're here with one of our players, Ryan, who plays Fletcher. So thanks for hanging out with us on Nature Chat today, Ryan.
Mm-hmm. Yeah.
Welcome.
So we were hoping that you could talk to us a little bit more about the player behind Fletcher. So tell us a little bit more about what you do as a scientist, and all of your normal day when you're not casting spells.
Yeah. Currently I am, my title is an Associate Director of Integrated Pest Management. So I do much more applied science and program and people management than research, or what people think a scientist is just in a lab doing research. But really, it's, you can be applying science anywhere, doing a lot of different things. So I manage IPM programs, but I do plant healthcare, so nutritional problems, diseases of plants, and I do this all in a public garden where we produce and maintain plants, common bedding plants all the way through rare palms. We've parts of our collection that are things that are endemic to single square mile patches of land in places like Cuba, and we have a specimen of that plant. And so we have to apply the scientific knowledge that's developed by people doing research, and we apply that actively to taking care of the plants. And then I do a lot of teaching and public speaking about mostly entomology. I do classes and field trips and all those kinds of things related to entomology. So that's what most of my day is nowadays. I got my PhD and then left academia immediately, and then started off in the nonprofit world.
So would you say, like, if you had to break down the percentage of your day that's spent like with bugs and plants versus the percentage of your day that's spent with people, like what is what's the ratio there?
Well, it's interesting because it's honestly all mixed together, because doing plant healthcare, which I think of plant healthcare as the overall thing that you're doing, and IPM is just part of a bigger program of plant healthcare. A lot of times entomologists get sucked into thinking of just IPM is how you take care of a plant, but it's absolutely not. And so it's all those deficiencies or problems or plant pests, and scouting them, diagnosing them, coming up with management plans, and assessing how things are working. All of that, part of that integrated management is people. It's not just the insects. So people are reporting things to me or diagnosing. I'm talking with them about what they need to do or how things are going. So it's really it's all tied together. And when you're actually performing IPM or running these kinds of plant healthcare programs, it's you can't exclude the people from it, and they're a huge part of the system. And that often gets forgotten about when people are doing research on just this is one kind of tactic we can do in IPM for this one kind of pests, and it's well, if the person doing that isn't managed properly, doesn't know what they're doing, they're not trained, it's all going to fall apart. So it's honestly, I can't separate the percentages because it's all one big wrapped up thing. Honestly, when you're actually out there doing it.
Yeah, I'm really glad you said that. I think a lot of people on both sides of, you know, whether you are a scientist or whether you're just thinking about scientists, forget that, yeah, we are beholden to our stakeholders and the people who need the information that we are researching or the information that we are distributing to people. So I'm glad to hear you talk about the people that you work with in order to do integrated pest management. So I know that like all of us in this group sort of know what IPM is or like how it works, but could you maybe explain a little bit more about like what is integrated pest management and how is that different than like other kinds of pest management?
Well, first I have a question. So the place where you work, Ryan, it's sort of like a kind of a zoo of plants, right?
It's a living collection. Yeah.
Mhm.
Yeah.
So and then people use that collection for research.
No, we don't have it's research or it's collection specimens. But we don't have like an herbarium on site where people would use preserved pieces of specimens. But we are right by the Carnegie Natural History Museum, which does have an herbarium.
Okay.
Yeah.
Yeah, because in the plant world, so the plant world is not very much like the insect world. So we have like butterfly zoos where we go and people go and see the butterflies. But botanical gardens often act as sort of a living version of an insect collection.
Yeah.
And people will, so like one of the things that people will do is there's a plant specimen, and I can't remember what exactly it is, that was originally collected and grown in the 1700s, and it's been in a botanical garden ever since. And they recently found herbicide resistance genes in it, so they're interested in figuring out why this was adapted. And so herbaria are used very differently in botanical research than insect zoos are in entomological research. And I just wanted to clarify the sort of institution that you were a part of, because it sort of becomes important.
Yeah, and it's a lot of whether it's conservatories or botanical gardens or arboreta, which are all different institutions. The larger ones that have not only the space but also the endowment and those sorts of things that can create a research program, they do, they'll have land where they do research for things, or entire greenhouses that are for research, and research is part of their mission. And that's true for big things like the Atlanta Botanical Garden, Missouri Botanical Garden, the Morton Arboretum outside Chicago. They do these kinds of active research programs. We just simply don't have the space currently to function at that high of a degree of research. But we are pretty recently created research department is expanding in order to do research with what we have. We are inside a public park in the city of Pittsburgh, so we're immediately constrained on our borders by the park. We can't move out of that, and then we're in a city. So that's a pretty different constraint than a lot of other gardens. So we can't expand. But we just got a plant ecologist, so we're going to figure out things we can do with the land that we have, where we are growing native plants and those sorts of things, as well as urban ecology in the very large parks that Pittsburgh has, and to try to use the space we have to do research. So it's growing, and it'll certainly be different than a lot of the research other botanical gardens do. But we're definitely going to start to break into our kind of own special niche of research.
Very exciting.
Okay, cool.
Yeah.
Yeah, so I guess my clarification question was, so
Yeah.
what's the difference between integrated pest management and other kinds of pest management that people might be more familiar with, or maybe we don't know anything about pests at all? Like,
Yeah.
what does that mean?
Yeah. Well, I think usually when people think of pest management, they're thinking of pest control, which usually traditionally, at least since the advent of like, the golden age of chemicals, chemistry for a better life, was spraying something to kill what was bothering you. And that's what pest control was. But chemicals are only one tactic to manage a pest issue. And so integrated pest management is uh, developing a program that incorporates all the compatible methods for managing an insect population for whatever your goal is, whether it's just keeping it below so it doesn't actually damage like our crop, so it doesn't reduce our yield, or maybe it's a public health problem and your goal actually is extermination. It's you have to define your goal. You combine all the tactics that will help manage that problem. So cultural controls, physical controls, environmental controls, chemical controls, biological controls if you're trying to control, a pest insect with another insect, all of those different things that you can use simultaneously to help both prevent the problem and delay it from ever happening, and then help decrease it after it does start to occur. And so that's really the big difference between, I think, what people think of as the traditional pest control and what IPM actually tries to do. And so my programs, we do combine every tactic we possibly can while actively avoiding chemicals, actually. And we're at about a 75% decrease in the amount of pesticide applications we do, just from the use of IPM. And what we do use is currently organic rated materials if we have to apply a chemical. And so when you're really dedicated to IPM, which is a lot more work to come up with and develop those programs, but you get really fantastic results. And most of the time, some pest will pop up, and I'll say, "Oh, I'm going to wait a week and see what starts happening." And when you go back to it, it's being eaten and parasitized and just destroyed by beneficial insects that are constantly present because we're not spraying pesticides. And so we get this continuous preventive biological control just present. And that kind of helps overlap between all the programs. And so it's a much larger focus on the system that you're managing rather than just a single insect as a pest. It's thinking about the whole system.
Yeah. And when you do that sort of work, you said it takes more effort to do integrated pest management rather than just break out the chemicals and start spraying. So does the IPM sort of pay for itself in terms of like ecosystem services provided by the alternatives to chemicals, or like, does it pay for itself in terms of like, even though it might be more expensive in terms of time and resources at the outset, it winds up being less expensive than the chemicals in the long run, that kind of thing? Yeah.
Yeah, I think most people end up seeing, if you're looking for just like the financial benefit, it's usually a benefit in the long run, is that it ends up being because you are not, you're not have that like addiction to the chemical, and that's the only way to get rid of the problem. A lot of times you'll have usually like a detox period where you're trying to do IPM and it'll be kind of rough for a little while. Because your only control is what you're trying to limit now. But once things are established, then you get into the period where you start having very few inputs into your system, whether it's chemical, biological, or even time management. If it's people scouting, or we do things of just hosing off plants at certain times of the year to just physically remove insects. That will start to decrease over time, and so even though you have an initial bigger input sometimes, which people don't want that cost, that eventually goes away over time. You start saving money because of how little you're putting into the system to manage the problem, because you're kind of helping the system balance back out by not just dumping into pesticides.
And it's working for itself.
Yeah, it works for itself. And like you said, the part of that comes from like the ecosystem services, that when you're not using an insecticide, a lot of times, if you're just spraying a broad spectrum insecticide and you're wiping out beneficial insects, you're not getting the help that they could provide you for controlling your pests. And so once those can recolonize your area and start giving you that control, you're getting that benefit for free, essentially. And so that's eliminating the cost of buying chemicals or buying other beneficial insects that you're inundating into the system. You can start having local native things that are doing the control for you. And we see a lot of that. Like, I love the summer because we open our greenhouses and stuff, and we just get all these native things that are then in and around those plants, and we just get amazing control from them.
Yeah, so why don't you guys use insecticides in the facility that you work at?
It's just part of the overall sort of green and sustainability goals of our institution, and we're really a leader in doing that for within conservatory and public garden settings.
Yeah.
And pushing towards that. The goal is complete elimination of using pesticides, and focusing on an IPM that, even though IPM does not mean we do not use chemicals, our goal is to end up having such a well-functioning IPM program for all of the issues we may have that we no longer have to use chemicals as part of that program. And so it's our push to be the driver towards that and serve as a model for more people to be able to do this, in the elimination of using those chemicals.
Yeah. So for the folks at home, I actually had a specific, I have a follow-up question, but for the folks at home, whenever you use a pesticide, there's this thing called a re-entry interval. So if you spray something, you can't go into the facility for a set amount of time based on what you're spraying. So like an organophosphate might have a longer pre-harvest interval than a pyrethroid. And, those are two different pesticides, with one of them being the OP organophosphate being more toxic than the pyrethroid.
Yeah.
Just by a little bit, by more than a little bit.
Yeah, by a lot.
That's either for using it in like a domicile, like a house or a office building or whatever, or into the field, because you said also harvest time, right?
Yeah.
Okay. Yeah. There's harvest intervals that you have to wait before you can harvest, and then there's entry intervals too, that if we have greenhouses, and we'd have to worry about that if we were using something in a greenhouse, because that's technically enclosed space production, which falls under agricultural use requirements on a label, which is when you usually start encountering those REIs, or those re-entry intervals.
Yeah. So the question I had is one of the reasons why you guys don't use pesticides to keep your facility open for longer. In other words, with the re-entry intervals, if you guys were to use a lot of pesticides, eventually harm, tourism efforts and stuff like that.
It would only affect that. I think before, and a lot of other places. I know of gardens that use, that they are closed certain days of the week because they are doing sprays, and like that's still their method of control. Like that's what we're trying to encourage people to get away from. Or there's other models. People simply do their spraying after they're closed for the day, so their re-entry interval can be all through the night, and then it's over before they open the next day. And then one of the other benefits, and this kind of gets to what Cheryl was talking about, with where you start seeing your savings and your benefit from doing IPM. Especially when you have something like greenhouses, where if you need to spray something, your workers are there, and then they can't go back into that greenhouse for 4 hours, you are essentially losing productivity time from them being able to work in that space. Nobody can do anything in that space while that re-entry interval is active. And so you're losing money because they're there at work and you're paying them, but they can't go in and do any additional portions of their job because there's that reentry interval. And so it's not that isn't the reason why we're not using pesticides. We're not using those pesticides as a choice to this commitment that we've made. But it's one of the additional benefits that we get out of this. In that, if the most that we may use at a time would be, like a horticultural oil, which is going to be, it's going to be like mineral oil you spray on a plant. And the only restriction is, nobody go touch that plant until it's dry. That's essentially the limitation that's on the label. And so it's just, so then you just, hey, like this is going to be sprayed on such and such bench. There's going to be the sign there. Just wait until it's dry. But you can still continue to work in the entire rest of your greenhouse. Yeah. And so there isn't that time lost on the labor side of it.
Yeah. No, I was curious about like the time lost due to customer and labor and stuff like that.
Yeah. Yeah. And yeah, so it's like you get around that, our conservatory portion of our is open to the public as well as our outdoor gardens. And so it's like, yeah, you could get around that by just waiting till we're closed and then spraying something at dusk. And then it'll be fine for people to come in the next day. But we've chosen to go away from that. Yeah. And not say, oh, we could do that and just keep spraying and it wouldn't affect our business because people can still come in. We have a very hard line delineation in where we have no pesticides that we use outdoors. We have extreme restrictions on things in the conservatory where the public interacts. And then our greenhouses where we have, licensed professionals working, we still have very strong restrictions. And if we're going to use anything basically more than horticultural oil, we have a whole system of assessing, do we need to do this? How are we going to inform everybody this is happening? So that everyone knows, this space is quarantined off and no one is allowed in there in a whole ordeal. And so it's part of our commitment to reducing our chemical impact.
Yeah. And, because I've moved from the entomology to the weed side, and I'm not going to get very far into this at all because this would be an entire nature chat in and of itself. But the weed side is actually way, way different than the insect side. I didn't realize how different it was when I came in, because that's what I'm doing as well. I'm doing IPM of plant pests and not insect pests, and it is so far removed, and that's a subject you and I should get into on another one of these. So, but yeah,
the difference in how different pest classes and in different systems and the way that research has been done in these different sectors all together and how they manage these things. When it's like, it's just very interesting how it's become so different between these different realms of different pests.
Yeah, and I would love to discuss that with you on another one of these. But so the sort of pests you deal with are largely just how do they get in, and what do you deal with?
I'd say we have the pretty typical greenhouse pests that greenhouses all across, Canada, Europe, United States, everywhere deals with, like green peach aphid and potato aphids, tobacco whitefly, flower thrips, greenhouse thrips. These are the things everybody deals with because they're so highly prolificous. They feed on so many things that they'll survive on something in your facility. Yeah. It just will. And then they'll move into, when you start making a very big crop of something, then they'll move into that and be very happy with it. So we deal with a lot of that. And so we kind of have known players in our greenhouses that as we monitor, we start to see something increase. It's usually a pretty good indicator, like, oh, that's probably going to be our like pest du jour for this season. It kind of changes year to year. But then we have a lot of tropicals. That's kind of our indoor thing, is that, we have a palm room and a tropical room, an orchid room. and a tropical forest exhibit that changes. And so we get plants from whose origin is from other countries. And so sometimes we end up with weird things. And so that's when you get the really interesting challenges of trying to figure out what the pest is. I've had something before that, I diagnosed it, tracked it down, found that it was recorded in like 2 counties in Florida, and that was it in the United States.
Oh boy.
And so got confirmation of what it was from the Florida State Hemipterist, and then sent them where we think we got the plants from, because didn't know it had spread to that location. And then we were up here in Pittsburgh, and we also had it.
Oh,
which is kind of so it's like, it's not something that would be known here at all. And that's where it's really the part of IPM with diagnosing and figuring out what you're dealing with and learning about its biology so you can figure out how to control it really comes into play.
Yeah, because there's been that reminds me of the gold spotted oak borer over in California. So I don't know how widely this story is known, but there's this insect in California that's destroying oak trees, and beforehand it was known from Arizona from like 6 specimens.
Mm-hmm.
Like we knew it existed, but had never really seen it before, and all of a sudden it's like, oh, all the oak trees in California are, it's just a really interesting story because it's so similar to this one that I've heard before, and it sounds like you guys pretty narrowly avoided a really bad ecological disaster.
I guess that's what I was going to ask about. So, like, how often is that a thing where, like, you get plants from other places? I know that's, if you've ever traveled between countries, that, like, oh, you're supposed to claim if you're bringing organics with you, or you're not really supposed to bring organics with you because we don't want this transfer of pests or other invasive species. So, like, how often is that a problem that, like, your garden gets new specimens from somewhere and they just have hitchhikers?
Yeah. Luckily, it's not that often because they go through those inspections. As they're crossing borders, coming through, they're inspected, and so most of the time it's a case where it's like what I was talking about. The plant material, it was eggs laid inside the plant tissue. So unless someone was specifically looking for that and was doing either a fluorescent or a dye-based assay to try to find these eggs, they would not have found these eggs. And so sometimes they can be hard to detect. But luckily, because it's tropical material that we get, and we're putting it in greenhouses in the conservatory, it's not a concern because once winter rolls around, it would all just die. Right. And its host plant is something tropical that will not live outside here in the winter. And so we luckily kind of have that like yearly quarantine that tropical things that come up into Pennsylvania, at least for now, the winter actually occurs and gets cold enough that it will wipe things out. So it's usually more of a concern for us to just figure it out and come up with an immediate plan for us to deal with it.
Yeah. So the sorts of plants you get, you mentioned you had some pretty rare and endangered ones. What's the story behind them?
So it's usually in the rotating exhibit we have that's represents different tropical forest biomes from different countries. Each show runs for about 3 years, and they go on curatorial trips to the countries to look at what the wildlife is, and they usually try to come up with certain plants that are endemic to regions in that country. So the plant only occurs in that area, and that's the only place it occurs in the entire world. So it's kind of like in the session that we just played, that plant that only occurred in that patch of beach in the shallows. It was endemic to that area. And so right now our exhibit is all about Cuba, and there are certain very small cycads and little palms that some are from. It's something like think there's a palm that specimen people have specimens as part of the conservation effort for these plants, which is why we have the specimen of the plant. And it's like it occurs in it's something like it's like a 3 or 4 square kilometer section of Cuba or something is the only place the plant exists.
Yeah.
And so we have it as to be not only part of the conservation effort of that plant, but because we're a conservatory, so we're a living museum, it's also part to educate people about, there are species that, even without climate change and all the other impacts humans are having on the world, they've basically always kind of been on the brink because they only exist in these little patches of land. And that's part of the education that we're putting out there to people as well.
And those are the ones that are very fragile and are most likely to be heavily impacted by even small changes in habitat loss or in climate change and weather patterns.
Yeah, it's like they're so limited where they live because it's such a special place that they live, and they're specialized to live there. And so, anything changes that, and things just aren't able to live there anymore.
Sometimes it can also be the opposite, though. Like with that gold-spotted oak borer I mentioned earlier. We knew about it for less than, we knew about it from less than 10 specimens, and just gets into a slightly different area, and that area just so happens to be better. I don't know.
And that's when that gets into the whole, what makes something able to be invasive, discussion. And then that gets into, well, part of that is a lot of times we make it easy for things to be invasive because, that landscape was dominated by people planting oaks as ornamental trees or et cetera, et cetera. And so when it was able to get into a place where it's all irrigated oak trees across California, it can just run right through and decimate everything.
Or like dandelions. It's it's this plant that loves low competition, freshly disturbed areas, and now we have that in the form of agriculture and lawns.
You weeds that it's like they can be invasive because they'll grow where other things won't, and they capitalize on that. So there's do you guys keep a lot of medicinal plants in there, and what sort of cultural relevance do a lot of the plants that you keep have in addition to the conservation relevance? I think the biggest part of that is, again, our tropical forest exhibit, because it's representing the country that they're from, but not only the biodiversity of the country, but the culture of the country as well. And so we do always include plants that are usually we have plants of medicinal importance, things in interpretation about, this plant has traditionally used for treating fever or headaches or whatever that may be. And then traditional plants of agricultural importance too. So we'll have a lot of cool things that people have never even heard of before as a food. But then we just have them in the conservatory. So I eat a lot of weird things that a lot of people have never heard or eaten before, at least in the United States, awesome. And that I just get to pull off of trees and eat all the time.
Give us an example.
Well, there's we have a species called the Malabar plum that's actually in the myrtle family.
Okay.
And it's now my favorite fruit. We have a big tree of it, and it produces these fruits that basically smell and taste like roses, like rose water. But it's basically an outer shell that you eat, and is then totally hollow inside with a loosely connected to loose rattling around big brown seed that's in the middle. And they're not juicy because there's no flesh. It's just this shell around it that
It's like a rose-flavored cracker.
Yeah.
Huh.
But it's still, but it's not dry. But it doesn't, it doesn't have flesh like a peach or an apple or all like.
Yeah.
And
Huh.
it's my favorite fruit.
Cool. Where's
Yeah.
it from?
I think Southeast Asia. I think that was put in when we had our Thailand exhibit. I want to say I think Southeast Asia. Syzygium jambos is the species name.
There's a lot of S's and Z's in that one.
Yeah, it is.
Oh, that's.
Man, we should have a nature chat all about scientific nomenclature.
Yeah.
Oh God.
Oh my God! Especially plants. When people come in and they're like juniper, cedar, and I'm like, that doesn't mean anything.
Okay. Yeah,
That means
that's.
nothing in plants. Like what you call a cedar is in juniperus and all, and it's just like you need to have a scientific name, or it's like it doesn't mean anything.
Yeah.
Like we had someone talking. Someone came and was giving a talk at our conservatory, and kept talking about swamp maple, and we were all like, "What? What is swamp maple?" And then he finished, and someone finally asked, and he was like, "Oh, swamp, Acer rubrum," and we were like, "Red maple?" And he was like, where he was from I think Rhode Island in the Northeast. He was like, they call them swamp maple.
Oh my gosh.
And I was
Yeah.
like, you confused everybody this whole talk because you never gave the scientific name.
Yeah.
And, I mean,
I
I
have-
totally recognize that like common names are useful, but like for people who don't want to memorize all of these ridiculous Latin names, but like man, they can get so messy.
Yeah.
Oh, I have a rant that I go on about about the usage of common names, and when we do our common scientific name episode, I'm just gonna go on a rant with all the hot takes, because I truly believe that the only reason that society hasn't adopted scientific names for insects is just purely circular reasoning on the part of scientists, and I have like a whole 10-minute uninterrupted rant that I can go on about this topic. And I'm probably like not even the only person in the scientific community. I feel like most of us could just get angry enough about this for 10 minutes just to go on a rant.
Everybody's got something.
Yeah.
My biggest thing with that issue actually is the whole science communication aspect, because I try so hard to sort of do my science and also make it accessible to people, and so when I do, there's a science symposium that is held at my research facility, which is really cool because that means all of the land managers and stewards show up and get to hear about the research we're doing, which is great, but they're not versed in the same sort of scientific disciplines that the researchers are. And so when I talk about like the dung beetles I study, they wanted to know, that was one of the most common questions for the audience, is, oh, well, what are the common names for these insects? And I was like, they don't have common names, because that's literally a thing. Like there are tens of thousands of species of insects that don't have a common name at all, and the only way you can refer to them is by their scientific name. And there's actually my first time at NSOC, I was blown away by the idea that like there's a committee that has to vote on and approve like newly submitted common names for insects, which I didn't know was a thing. I thought common names just sort of like came out of the common people, and like that's what you call that thing. But yeah, so
yeah,
the naming thing is just
well, we need to. There's some common names that I feel like we really need to change. Not because they're useless, because all common names are useless. They have absolutely no practical use whatsoever. But
if you want to get really nitpicky, species is just a social construct.
yeah, it's just lines and artificial lines, and I've pissed off taxonomists by pointing this out before, but they are artificial lines and pure gradients, and the only reason those lines ever break is because things go extinct. But no, like the Oriental cockroach, for example, and this isn't even the most offensive thing that I can think of, because there are butterflies that are, there's a butterfly that's named after the N-word. But like I would really like to see some of these common names change, because they get fixed in, early in culture, and then as culture evolves and we start to think to ourselves, hey, these names are harmful to specific groups of people. I think Terry McGlynn was talking about the gypsy moth.
Yeah.
Yeah. or
Because
gypsy ant.
he had named an ant the gypsy ant before when he hadn't thought of the connotation of the word. Yeah.
Yeah, so I'd like to see some of those change. But no, other question: the medicinal plants that you guys
Hmm.
have.
Yeah.
Do you guys have any that would be considered medicinal, and what sort of precautions do you have to take with those?
There's no precautions that we have to take. Um, and besides what we have in the tropical forest, we have like a more traditional European medicinal plant garden that we have outside, which is probably the things people are more familiar with in the United States. So we have like an apothecarist's rose, where you get the really big rose buds that you can harvest and dry and turn into teas and stuff. Um, uh, and like chamomile, and lavender and those sorts of things. Like, so we just kind of display those things, and so people are really familiar with them, and there's no precautions really. Like, people aren't taking them from us or like eating so much of it's going to cause some bad effect or something, because we have an individual specimen of each plant.
Yeah. Yeah, because when I was, oh God, I want to say this was, so there was, and I'm not gonna say, I decided to not say where it was, but one of the schools that I've gone to, um, has a peyote plant in their garden, and they have a specific section of plants that are culturally relevant for religious ceremonies that are hallucinogens, and I don't remember exactly. The only one that I remember is peyote, but they actually have it sort of in the back and not really visible, and it's unlabeled, and you're not gonna find it the way that they have it, and that's. I think that's about all I can say about how they hide it. So
that's an interesting consideration, though.
yeah,
yeah. We don't have anything like that. 'Cause otherwise, yeah, you would have to make some kind of consideration. I think the thing we worry about the most is probably like our desert room, because we have open cacti just all over next to paths and things, and so it's like that's probably the only thing we really have to worry about.
yeah, yeah. So to go back in the to the session, it's not like you have little fish guards running around and armed with crossbows.
Yeah.
I just want to say, speaking of like safety things with plants, I was like, oh man, Lucanus is chewing on a plant that he has no idea what it is. I was like, oh boy.
Yeah, no, and I did that specifically so we could bring it up and talk about like like what plants are edible and what plants are medicinal, and I tried to make a little biosecurity boo-boo so that you could talk about like how are people supposed to interact with the plants here, because I'm sure that they do it in a very different way than they might do it in the wild. Like even if I knew what sort of plants were edible, if I were to go and pick off a fruit and start eating it in your conservatory, you would probably not be very happy with me.
Yeah.
So like, what are the sort of differences like between how people act in the wild or how people act, in the conservatory?
I don't know how much I should talk into that, because we saw a lot of my own like opinion about people interacting with our space.
Yeah. Oh, that's fair. I didn't consider that.
There is definitely a difference in that, when people are in an experience that is fairly built for them to experience it, they feel much more allowance and ownership to do what they wish versus in the wild.
That's odd because I would not think about like walking through. You said it's a museum for plants, so I wouldn't think about walking through Chicago's Field Museum and licking specimens. But I can definitely see what you mean. That like, oh well, this is a controlled environment versus the wild, or as the New Sachester people call it, the out there, right? And the out there is very dangerous and it's not controlled. But like, oh well, if the plants are in the conservatory, they must be safe, right? So I can definitely see that like cognitive disconnect.
Yeah. So
yeah. Thank you for talking to us more about what you do, Ryan, and talking to us about endemic plants and pest management and all kinds of cool stuff. What you do is really neat.
I do a whole host of stuff.
No, keeping plants safe is one of the most interesting and complicated fields, and as I said, I'd love to I'd love to explore the difference between what you do and what I do in a nearby episode. So
yeah, definitely.
So all right.
Thanks, guys, for having that talk, and thank you, everyone, for watching Nature Chat. Don't forget to tune in live on Twitch or on YouTube, Periscope, whatever, for session 4 of Nature Check, where we're going to have our first special guest. So we will see you guys later.
Yeah. Take care.
Bye-bye.